Recorded. This session is being recorded, and let's begin. So if you can remember, last week, it's visible. Last week we were going through the delay of advancement, right? Now, today we'll be building from that, in a sense that today we'll be doing the opposite. So we'll be delaying when our cylinder retracts, right? So just a recap of this one, and then we'll start with the new circuit, right? So in this new circuit, we introduced a timer, right? And looking at the first network there, because we were delaying advancement, we, instead of having our I0, we substituted it with the output of our timer, right? And then on the timer, on the latching function block that is connected to the timer, we used the I0, right? That is our start button to set our timer, right? And then we used S2 to reset, meaning to allow for the cylinder to go back to its initial position, to retract, right? Now, one thing that I forgot to, one thing that you should get in the habit of is always having a stop button. That is when you are delaying advancement of your cylinder, right? So here, what we need to add is our stop button, right? So if we add our stop button, you will realize that we can stop our process anytime, right? Even in the middle of even before the timer completes its time of 5 seconds, right? So we're gonna, for now, before we go to the next exercise, we're gonna just put in a what you call a stop button, and then see how our second functions, right? Okay, let me just open my preparation here. And on your Festo software, you might want to check if you're on OPC mode, right? Because otherwise, your program, the softwares, they won't communicate with each other. Okay, so also let me check if my OPC is working. Okay, sure. So yeah, you'll always find that like once you close your program and you save it, the next time you open it, you won't be on OPC mode, and this is the mode you should always be on, right? Then I'm just gonna click OK. Then I believe all is set. And then you'll see that on your modules there, fluid sim out and fluid sim in, it'll go back to its initial state of virtual PLC.EB0 and virtual PLC.AB0, right? Okay, so I'm just gonna extend that. So remember, for this exercise here, for this exercise, we are getting a stop button, right? Okay. So let us put it under our I0, right? So you'll insert a negated contact because you'll insert a negated contact below, parallel below, because your initial state is always on, right? For your stop buttons, it's normally closed. So for normally closed states, we negate them when you come this side of your ladder logic, right? So insert negated contact below. And this is our stop button is I1. So what should happen is once we start our stop button, as the counter starts counting, we want to see if we press the stop button, it will stop the whole process, right? So that we're in control of our system, right? So I'm just gonna go to build. Always get in the habit of building before you run your model, right? So I'm just gonna build, and then I'm gonna log in, download, then click yes if you see this pop up. Then press play. Okay. Okay, I just want to see the timer, right? So if we press start here, okay, let me just fix this. Okay, so it's actually let's run. So actually, I connected the stop button in series, not in parallel, right? And you shouldn't change that a contact. It should be a normally opened one like that, right? Okay.
it's not. This one, that is just showing them stop button. Okay. So that yeah. And then you're gonna connect them. Yeah. That is like this. Sure. Okay. Okay, guys. So we should actually connect the stop button and the emergency stop in parallel with our sensor. So these will allow us to stop our circuit at any time, right? So I'm just gonna connect that and run our circuits. Before I forget, let us negate that. Okay, and then let us log in with download. Then press play, right? Just gonna split these screens. Okay, so okay, I'm not getting communication. Let me just fix the communication the side. Sorry? Okay. Is it not breaking the connection? The communication is not there. It's actually here.
Okay. It's awesome.
Let's not get launched there. Let's double check it.
Okay, guys. So we have now established connection. We are connected to the local host. Okay. Let me just go back to my model. Okay. Okay, so if we can try to run it now, run our Festo or fluid sim. So if you can observe that our advancement is delayed, right? But now that I introduced our stop buttons, our start button and emergency stop button, if you can observe, I will just restart the whole process again, right? If you can observe what will happen, so let me just run this. Okay, so if I press start, you check the timer. Okay. Okay.
No, leave that.
Yeah.
Come here. Take care.
Okay. All right, guys. So if I press start, I want you to observe something, right? Observe the timer and observe when I press stop. So before the counter stops counting, if you press the stop button with this connection that we have modified, your advancement will not start, right? But so we are doing this so that we can have complete control over the system, right? So it's always a must. It's always important that you have stop buttons, right? If you don't have stop buttons, you won't be in control of your process, right? And even for your test, make sure that you always are having some kind of a stop button, either the two. But it's important to have. You can have one, but it's important to always have the two stop buttons: your stop button and your emergency stop button. Remember, your emergency stop button. Once you activate it, your system can never work again up until you reset your emergency stop button. So that's the reason why we have two push buttons. With the stop button, what it does is just stops, but like you can start at any time, right? So that's the difference, right? Now for today, what we'll be doing, we'll be modifying this in a sense that we will be delaying advancement, retraction, right? So, okay. Okay, so in this case, guys, what you must know that what sets your retraction to be delayed is your center 2, right? Proximity center 1, right? So what will alter here is that we'll replace I0, with S2. Let me just go out of simulation mode. So now we are delaying retraction, right? So remember, in advancement, it was I0 that was responsible for delaying our advancement, right? But now it's S2 that is delaying our retraction, right? And then what resets our connection is your I0, and then your okay. So what sets what delays your retraction is your center 2, along with let me just put equation and your stop buttons, right? Trying to okay. So actually it's here. So okay. So we'll now swap our memories. So I0 comes back here, right? And then we're saying I2 is the contact responsible for delaying retraction, right? So we swap that with I2, right? And then we have this kind of a second.
Okay, where did I lose you? So now we're doing a delaying of retraction, guys. So remember, in the previous one, it was I0 setting our timer, right? But in this case, it's sensor 2, right? That will delay retraction. So once our cylinder gets to sensor 2, that's when our counter, our timer will start running. And then once it reaches 5 seconds that we've defined here, it's gonna retract, right? And then what will stop that whole process is our I0, which is our start button, our sensor 1. I mean, our sensor 1, I don't know why I'm doing that. So it's not I0, it's yes, it's I0 along with sensor 1 here. S1. Right. So and then you will always need your push buttons to stop the process at any time, right? Okay, so if you have this kind of a connection, what should happen is the cylinder will initially advance, and then before it comes back, it will count for 5 seconds and then retract, right? Okay, then I'm just checking everything is, if it's all right. Okay, here it's just I2 here, I2, and then your M0 should be here, see, on your sensor 2, right? Okay, everything is set, and let's build our model, right? And then download, log in with download, then click OK, and then press play. Okay, so I'm just gonna split my screens and just okay, let me just do this. Is it doing as it's supposed to do? Huh? Yes, no. Do I have a yes? Okay. The ones that have done it, can you show the other guys your connection? Just look at the connection first. Make sure your contacts are correct. Okay, so I'm gonna run on my side. Okay. Oh, sure. Okay, if I can press play on my side, this side, it advances, and then look at the timer there. It advances, and then counts down, and then once it counts down, it goes back, right? So I'm just gonna show you the network so that you can check the connections. The lady there, did you connect like this? Hmm? I'm saying you. I'm talking to you. But like your OPC, is it connected? Connecting to local host. Just try to, what's this? Let me see. Is it on version 3? because you should be connected to the local host. The guys this side, is it connected? Yes. It's not connected to localhost. Yeah? It's connected. And then is your circuit running accordingly? Okay, can you check your connections there? It's definitely your connections because mine is running this side. Otherwise, just close your. Also, make sure you're on simulation. Are you? It's fine. Okay, let me check something. And then your fluid sim, is it AEB0, AB0? Your modules. Is it AB0, AB0? If everything is fine, I think it's like a troubleshooting issue. Just try switching it on and off and see if that works. Like save your project, all your projects, and then open them again and see if it works. Okay, guys. So, but in the meantime, we'll move to the next exercise, right? You watch the recording. We don't have time as it is. Yes. It doesn't move again. So it does everything correctly. Yeah. Oh, it only does one cycle. And then did you check the connections are the same? Okay, if that's the case, just try stopping and starting your simulation. It's done. Because yeah, it shouldn't do that. What it should do is that once you run a cycle, okay, you should also mine is doing the same thing. It shouldn't be doing this. Let me check something. Okay, can you delete the sensor one there?
When focus but not when you're turning off the don't to me.
Yes, hold on.
Don't to you still need it. So, don't make anything parallel.
Okay. So my guy, the problem we did was we were in series, and in terms of it should be in parallel, right? So if you can run it again, it should run more than once, right? So as you can see, I advance and then it goes back, and then if you can do it again, it does the same. So the problem is with the parallel connection. It's working in series connection. Okay, if it's running, then it's running, right? But apparently you have to. It's best practice to put it in parallel. Right? But if it's running, that's also good. Okay, so the next exercise that we'll be doing is continuous running of your circuit. So in the scenario of having a lot of products, for example, going through a conveyor belt, and you want to maintain your cylinder running continuously up until you want to stop it, this is when we do that, right? So now we're gonna do it's sort of an infinite loop. So your system is running forever, but you can always choose to stop it at any time, right? So now we'll be doing a continuous circuit, right? That runs forever, right? So okay. So how you'll do that is you will start. Let's first go out of simulation mode. So how you'll do that is you will create a stop-start circuit above all your circuits here, right? So that stop-start circuit, you will latch it so that it can continuously provide power to all the other circuits. But we'll analyze that and you'll understand it better once we have created it. So you're gonna click on the first network there on the side, and then you're gonna right click, and then you're gonna say insert network, right? And then you will see a new network above there. Now, remember your stop-start circuit only has one output, right? So remember this for anything, for any circuit that you're told that you need it to run continuously, you have to have a stop-start circuit above, right? So we're gonna have a you can copy this circuit, and then you can paste it there, right? And then because it's a stop-start, we're gonna just remove this output, and then we won't need this memory. And then we're gonna also, let me see. Okay, yeah. So this circuit here, it's your stop-start circuit. As you can see, if you can analyze it, it comprises of a start button, a sensor. So these two here are for end position sensing, right? So as it is here, it will sense the retracted position, right? And then there you have I1, I2, which is your stop button and your emergency stop. And then now I need your attention here. Now we're going to create another memory, right? So this memory is for you to maintain current passing through the circuit through and through, so that your circuit always receives power, right? Current, right? So we're gonna have M1, and then we're gonna also latch it here. Before that, let's say. Okay, so we're gonna have M1, and then once after typing it in, just click enter, and then click enter again. So enter twice, and then where you defined your M1, right? So remember, this is our stop-start circuit, right? And it's the circuit that will be responsible for giving power to all the other circuits forever, in a way, if I can use that word, right? And then also here you latch that, then we click, yeah, you can click enter. So as you can see, your output here is latched, meaning there's continuous current flowing through M1. Now this very same M1, you're gonna use it for setting your time, right? So remember this this exercise, it's continuous. It's a continuous run of your circuit. Your circuit will go forward and back, forward and back, forward and back, up until you press a stop button, right? So because your time your output of your timer is M0, right? So your output of your timer will be responsible for starting the movement of your cylinder. So we'll substitute the output of your timer to I0, right? And then we can have what's this? We can remove S1 there. Okay, we don't really have to remove S1. This is for end position sensing, right? And then we're going to have I1, I2, and then we can delete this one. Right? And then because remember that M1 that we defined in the first circuit, we're going to put it as a contact that sets our timer, right? So we're going to put M1 here, right? And then we'll have S1 in series, center 1, and then we'll have our stop buttons, right? So for the timer, it's S2. It's S2 that resets your timer. So we're going to say S2 here. And then we have our stop buttons, as always, right? And then with this circuit, it will run your cylinder, so it will advance and it will retract continuously up until you decide to press the stop button. So just a recap, right? You create your stop-start circuit, and this stop-start circuit, its output will be memory 1. You don't use you use memory 1 because you have already used memory 0 for your timer, right? So for your memory 1, so for your stop-start circuit, you'll use your memory 1, and then you will latch it, right? So remember, when you latch using a contact, right, and not a coil, right? And then after that, we are saying this memory 1, it will be responsible for starting our timer, right? So as we press start, the cylinder will count down and then it will go forward, right? And then it will come back and then so on and so on, right? And then we're saying that M0, the output for M0 is your new input. It's your I0 in a way. It is substituted with your I0, with your start button, right? And then, as you can see, it will now be able to energize your Q1 and Q0 continuously, right? So if we can run that and see our circuit. I'm just gonna split these screens. Okay. Okay, so what I want you to observe is the cylinder, right? And also let's also observe the timer. So if you can press play, the timer will count. Okay, let me just stop that. Okay. Okay. Okay.
Press this thing. Say.
Okay.
I'm saying press the other one, the upward. Yeah.
This one. This one.
The upward.
This one.
Yes. Zoom down. Control zoom. Control zoom. Yes.
Okay. Okay, so that they can see everything.
So why is this stuff?
Seems like what is now setting it off. Let's reset sensor 2.
Why are you not referring to diagram?
Yeah, it's working this fine. The diagram is fine.
Then this 20 is cool. Yeah, I see. I want to see.
I see. Okay. Yeah. Okay. Then this is. Yeah. Okay, guys. So we don't need sensor 1, right, for this one. Okay. If you can run it, it will now run continuously, right? So it's stopping our our cylinder from going back, right? So that's sensor 1, right? So if you can remove it, you will observe that it now runs continuously. Let me just restart that. Okay. Okay, I'm just double checking on my side. Okay, so I forgot to put our sensor here. S2. And it must be negated. Okay. Okay. So remember, this S2 is for when the cylinder reaches the advanced position, so that it can go back, right? And then also here on the 3rd second, S2 is the one that resets the timer, right? Okay, then we're gonna just run that. Explain. Okay. Okay, so as you can see that, okay, I think I pressed stop. Okay, so it runs once instead of infinitely. Okay. Okay, so it runs according to how it runs correctly, right? So what happens is every time before it advances, it counts down 5 seconds. If you can observe the timer there on the right. So every time before it advances, it counts 5 seconds, right? And it will not stop up until I press the stop button. So if I can press the stop button, observe the time there. The timer resets to 0, right? So that's how you connect your continuous circuit. Right? So I'm just gonna press stop here, and we do the last exercise, which is we delay when it retracts, right? Okay. Okay, so for retraction, it's gonna be the opposite, right? So it's you should know that, like, with advancement and retraction, you just swap contacts, right? So in this case, our start will be the same, right? And then so you always, with continuous circuits, your stop start always is the same, right? And then you just change the 2 circuits below here, right? So remember, here it was your output for your timer was setting our timer, right? But for this case, because we want when the cylinder goes back to delay before it goes back, we'll now switch M0 with our S2 here, right? So here we'll put M0, and then here we'll put I0, right? Yes, so remember in that previous one, the memory for the timer, it was being substituted with I0. In this case, because we are saying sensor 2 is responsible for delaying retraction, we substitute the output of the timer with sensor 2 there, right? And then here we will have sensor 2. We will have sensor 2 starting the timer, and then we will have sensor 1 stopping the timer. Okay, and then we have our push buttons there to stop the process at any time, as always, right? Okay, okay, let's just analyze that. So what will happen is we'll press our start button, and then it will activate our memory, right? Now, the memory is latched, right? So what will happen is once the cylinder gets to sensor 2, it will activate M0, right? And then M0, oh, okay, I'm forgetting one last thing. Just this. So where I is, that's where we'll put our M1. No, let me check. Okay. Okay, let's run this and see if it will run. Otherwise, we might need to troubleshoot, right? Okay. So is it running? It's running once. Okay, let me check. Okay, so yeah, remember, we now have to put, so remember, M1 is responsible for producing, for allowing current to flow forever, right? So we have to put it in place of I0, right? So we have M1 there. And then what will happen is once our timer is, the output of our timer will now will start counting when the advancement, when the cylinder reaches sensor 2, right? But like we have M1 here, so that there's constant current going through our system, right? So if you can run that and see what it gives you. Let me just see. Yes, you are right. I should build. If you can see here, it's not checked, right? Otherwise, it won't run correct. So let me check this box. Thanks for that. Okay. Okay. Let me just stop and start. And press play. Okay, let me just stop at the side. Okay, it's not run. It's not okay. So as you can see, when it gets to the advanced position, it counts and then it goes back. Goes forward, it counts, and then it goes back. Sorry? Which push button? You pressed one. That's shouldn't work like that. So you see mine, immediately when I press stop, it stops at any time. And then when I press the push button, it works. Hmm? I think it's just a glitch, but if you can observe here, once it advances, it waits a bit, and then it goes back. And then it goes forward quickly, and then it counts 5 seconds. You can even count, and then it goes back. So it's a glitch on the chorus side, but it's running perfect, right? So yeah. So yeah, guys, just familiarize yourself with the concepts for today. Continuous circuits, because there's a high likelihood that you might be tested on this circuit, right? No, not this one. Not this one. I'm not saying this one. But obviously, we won't give you an easy circuit. But it's based on everything that we have done. You just need to practice. That's it. But I inform you what each contact does, isn't it? Huh? So guys, for next week, we'll be doing the assignment that you have is, we'll do it together next week, is that create a circuit whereby it delays advancement and retraction, right? And then we'll also do a question paper from last year, and then I believe after that you'll be ready for the test on the 17th, right? You are welcome to consult at any time, and yeah, that's it for the class, guys. Huh? Yeah, you can come. If it's not marked, I'll mark it in front of you. It's fine.